Good afternoon, students. I'm here today with my friend from college, Mr. Nicholas Garner. He's studying physics at the University of California at Davis. And he's here today to tell us a little bit about the stuff he studies and how he got into the physics gig. It's great to have you with us here today, Nick.
Thank you. I appreciate being invited to speak here today.
Awesome. So, can you tell us? We know you study physics, but can you tell us, just for those people who might not know, like what is physics?
Physics is the study of motion. In particular, it ranges from the very small to the very large. There are roughly two realms of physics. There's the astronomical and universal, studying the formation of galaxies and stars, like our own solar system. On the other end of the spectrum, there is the very, very small, particle physics, string theory, things of that nature. I am more on the latter. In particular, I study high energy physics, quantum nonsense, and things of that nature.
Can you tell us a little bit what you mean about what do you mean when you say a quantum nonsense?
Yeah, so there's this subatomic world that you may have heard of. There are these things called atoms. Of course, you've heard of those. Within atoms, there are
You guys
particles that make up atoms. Neutrons and protons make up the nucleus of an atom. That is what determines the atomic number of an atom, how many protons it has. There are also electrons that are buzzing around the exterior of an atom. But one thing you may not know is that protons and neutrons are not themselves fundamental objects. They are actually built of yet smaller things. The universe, as we understand it, is built up of these smaller things. Such things are electrons. Those are believed to be fundamental objects. There are also quarks, which build protons and neutrons, and various other force-carrying particles. By that, I mean things that allow quarks and electrons to talk to one another.
Can I
The
ask
most,
a clarifying
yeah,
question? Is this the 12? There's like a 12 particle model. Is that
so
is that something that still
there,
exists? I'm asking
so
for myself
yes,
here.
yes and no.
Okay.
Um, I would say that there are 12 matter particles
Okay.
that we have been able to find. The distinction between those are as follows. There's half of them called leptons, which are electrons and their heavier cousins called muons and taus.
Okay.
Muons are very interesting particles that I could say a lot about. In particular, they can be used to show the existence of Einstein's theory of special relativity, amongst other things.
Cool.
Also within,
Can I
oh,
pause you for a
yes,
second? Yeah, yeah. I'm
of
just
course.
gonna, for the people watching this video, there's a good TED talk from this guy at the CERN Center at the Large Hadron Collider. So I'm gonna put a link to that down in the description of this video. So if you want to learn some of the more like the basics about the elementary particles and forces and whatnot, he does kind of a survey of that.
Highly recommended.
Yeah. Have you seen that TED talk?
No, I have not.
Okay. Well,
But anyone at
if you
CERN is
wanna
bound to
also,
tell you great
yeah,
things.
he's probably yeah, he seems like quite an expert. I think his name's it's Brian something or other. I
Brian
can't remember.
Cox.
Yeah, 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 yeah.
Yes, he's infamous.
Ooh, really?
No, he's
Well,
really great.
okay, he's good.
He's has many really great tricks that he can teach you about. Lots of science facts.
Okay.
Also really funny. Highly recommended. He
Cool.
has some good books too.
Does he? Okay, cool. Maybe I'll look one of those up, and I'll. So once again, I'll put the link in the description of this video for those of you who are like curious about learning a little bit more about that. Just so we don't segue these poor high schoolers with too many muons,
Yes, of
because
course.
their brains will explode. Also, guys, if you want to learn more about muons, I'm happy to forward any questions you have
Oh
to the
yes,
future Dr.
there's
Garner.
lots to learn.
Yeah. Um, okay, not to totally blow you off completely and ignore all the cool
Not a
research you're doing.
problem.
But so like, what do you do like on a day to day basis? What is that? What is like an average day in the life of a physics physics PhD student look like?
Well, it varies depending on one's discipline. I was mentioning that there's sort of two fields of study, the very big and the very small, but there's also a separate delineation between experimental physics and theoretical physics. Experimental physics is usually what you think about with physics, where you look in a telescope to try to understand what elements are in some star, or you build a giant particle collider and ask what sort of fun things come out the other side. I'm on the other side of the spectrum, the theoretical side of the spectrum. If you've seen Big Bang Theory, this is not so far from Sheldon Cooper, if you know the name. If you don't, that's okay. The big picture is that I sit around in front of a whiteboard or blackboard, whatever seems to be in front of me, and I stare and think really hard. Large portions of my day involve just thinking. I do math all day long.
Sounds really fun
It's
for you.
exhilarating.
For you guys, for those of you who are thinking about like math from the point of view of your math class and just like sitting there doing calculations, I've seen the kind of math Nick does, and it's like a lot more fun and a lot more interesting.
It's all based in the pre-algebra you're learning now. Calculus is another tool that is bread and butter to me, but it goes far beyond, and I highly encourage you to pursue a degree in mathematics if you're interested in those things. It is much more than solving for X, I promise.
Much more. I even know enough to say that's true. So even as a biologist, so is there? So like, what do you? I'm going to rephrase that question because that was gibberish. So what do you like about studying physics?
Well, the way I see it is it's all a big jigsaw puzzle. I have all of these bits and pieces, and I kind of have some rough idea of what it's supposed to look like. I can see the front of the box. I know, oh, this is going to be a dog. I know what picture I'm shooting after. But then going through the nitty gritty of looking at this piece, oh, that's an eye, maybe it should go there. These kind of are the same color. Let's put those together. It's all a big puzzle, and being able to have a lifestyle supported by solving jigsaw puzzles is far beyond anything I could have hoped for in my life.
That's super dope.
So, to be completely honest, the fact that I'm getting paid to do math is a dream.
It's like the true nerd's answer.
Yes.
I love it. Are there things that are challenging about
Oh yeah,
being?
certainly.
Care to elaborate?
One aspect that is hard is that mathematics is incredibly difficult. I am well versed in many maths, and there is many more maths that I hope to learn, and many more maths that I know I will never learn. More realistically, having no set schedule can be difficult, in particular in high school and even in your undergraduate education. You have like homework that has a deadline. Oh, I have to do this by next week. Oh, I have to finish this lab report. I have to do X, Y, and Z. Distinction with graduate school, or at least the later portions of graduate school and any career in science, is that you don't quite have those same deadlines. You don't quite have the I need to finish this lab report by tonight or so on. In particular, what I mean is that you set your own schedule. You choose when you work, and if you don't get it done, then you are the only one liable. Finding the day-to-day inspiration to sit down to do math is even difficult for myself, but it's really rewarding when you get to find the full dog in your puzzle. When you find even a small portion of its ear, it's truly satisfying because you know, oh, I'm that much closer to my dog.
That's super cool. And is this what you want to do? You want to go into academics? Is that what you want to do with the rest of your life, or?
Yeah, I would really enjoy the opportunity to do math for the rest of my life. As I said, it's certainly a luxury to be paid to do math.
Yeah,
And if I can keep doing it for as long as possible, I would greatly enjoy it.
awesome. And then last question, uh, or I'll let you put in any comments you want at the end. But last question for me is there any advice you would give to young people who are interested in studying science of some sort for a career?
Never stop learning. Full stop, never stop learning. That's kind of vague. What I mean by that is, even though I've been in graduate school for 4 years, I've been studying physics for almost a decade, there's still so much more to learn, and I don't think I'll ever stop learning. So if you hope to pursue any science or anything in your life, regardless of whether it's science or not, keep learning. I have interests beyond the realm of science, and I learn about those things as well. Being able to learn for a living is unparalleled. I think that if you have the opportunity to learn, you should continue to do so for as long as you can.
Awesome. Well, thank you so much. It's been a pleasure talking to you. Guys, if you have any questions for Mr. Garner, you can contact me directly, or you can put them in the video comments where either he or I can respond and help you out. Thank you so much.
Of course. Have a nice rest of your day.